My name is Vincent. I work for a company and I solve data problems. I'm currently sort of still the chair of PyData Amsterdam. We organize a meetup as well as a conference. Please come by. I'm also sort of not really our studio partner, but they had my face up at their website. I work with these people sometimes. They're lovely people. I love our studio. I also organize a meetup. In about a week, we're going to have a meetup about the Internet of Cows. There's a couple of people who put sensors on cows to sort of, if that's bovine artificial intelligence, sounds like fun, please drop by. There's also some other guy talking about streaming matrix factorizations, which is, I guess, more the serious topic, but please drop by the Applied Machine Learning meetup. I have a blog at Koning.io. I'm a diehard Bayesian. This is sort of what I am. This is what I like doing. I'm here kind of on my own, on behalf of my company. And one thing I do want to mention is ING, thanks. I am a proud customer of you guys. That's, I really like my orange bank card. There's a certain percentage of people who work here. No, but another reason why I would like to thank you, I organize PyData, I organize a bunch of stuff, you guys always sponsor, so once again, thanks. It really helps, definitely thanks. Come talk at my conference, please. Today I will talk about, so when Joe approached me and said, Vincent, we were sort of looking for a speaker, do you have anything cool you might talk about? I said, oh, I have this fun data set about World of Warcraft, I could kind of talk about that. And as I was sort of preparing this more and more and more, the more that I started considering, I don't really want to talk about the World of Warcraft data set. I kind of want to talk about this programming language that you guys might be able to figure out is R. So yes, I will talk about H2O and a little bit of how you can do Spark with R and sort of the background behind it. But what in the end we're going to end up talking about is this thing called R language, and there's some great parts that most people aren't aware of at all, but I kind of want to shed some light there because there are some things that R can do that will basically guarantee that it's going to be around for a while. And there's this weird thing whenever I talk about R, because there's this sort of language battle. It's kind of when you talk to Python people, they always give sort of a small rant to R. And from a person who does R and Python at the same time, it feels really weird. It almost feels like there's dog people and cat people, where Python are the dog people and R people are like the cat people. And the problem starts when a dog person looks at a cat expecting dog behavior. That you get sort of these weird sayings like, that's not how data science is supposed to work. And on my side, it really feels like this, that someone basically looks at my cats and says, your dog is broken. This is a metaphor that I will use for the rest of the talk, but it really does feel like this sometimes. This is the average response from a Python user. And I kind of get it, because R is a language that definitely has some strange parts. It's like these two cats that live in my house. But they more than compensate for it with great parts. And sometimes people focus on the bad parts and not on the good parts. And the good parts aren't just good, they're actually great. Having said that, I love Python. It's a great scripting language, it has great taste. But I really feel that because I've spent a lot of time and effort understanding how R works, that I'm a better professional. And I kind of want to share some lessons with you today. So my goal is to talk about the great parts. Again, bad parts exist. I'll briefly talk about those as well. But while I'll be talking about why R is such a cool tool, we'll also talk about different backends. We'll talk a little bit about TensorFlow, a little bit about H2O and Spark, and different backends in general. We'll discuss how we deal with these other languages, these other tools as well. Because we'll find out R doesn't really care what tool you're using. You can use it from R. We'll also understand some more advanced R tricks, and at the end I'll conclude that there's going to be this new thing coming that's kind of like a DSL for machine learning, which I hope to make you guys a little bit excited about, even though there's nothing official about that. Oh, I'm also going to talk about a fun data set, namely this one. If you go to Kaggle, we all know what Kaggle is, right? Right. So Kaggle is this website that used to just host machine learning challenges. Then everyone just started doing ensembles, and there was hardly any competition anymore. But nowadays it also hosts cool data sets. And one of my favorite ones that I like to use for trainings is the World of Warcraft one. This one in particular looks a little bit like this. So there's a data frame, there's sort of like a log file of what World of Warcraft characters are doing. So at some point in time, we had a level, level 18 orc shaman who was in the Barrens, let's say. And the Barrens is sort of a province in World of Warcraft. And we basically have a data set that kind of looks like this. And about every 10 minutes, we kind of get this log of where this person was. And this is kind of a cool data set. It's not just because I'm kind of geeky, but the thing to remember about World of Warcraft, I think there's about 10 million people playing this game relatively seriously. Right? It's like a goal in someone's life kind of a game. So just from this data set, you can calculate a couple of things. Like one thing you know is about 40,000 players, a little bit less. There's about 10 million rows, and it's basically lots of random players that were playing on a single server of World of Warcraft in the year 2008. So it's a pretty old data set. to be releasing just now, but this is what we have. And if you want to calculate these statistics in R, it's actually super easy, because the way you can do this, and I'm just going to read what the code says, and then hopefully it feels intuitive. What you can do is you can say, hey, take the data frame, then summarize it by saying the maximum date is the maximum of the timestamp, the minimum date is the minimum of the timestamp, and I made a small typo, but n equals n apostrophes should be count the number of things in there. What I hope, at least intuitively, who has never programmed in R before, by the way? Before I start explaining. Okay, so to whom is this obvious? Because then I can just skip a little bit. Okay, I'll explain. What I hope is that this reads somewhat as a human would read a book. It's something that you can read from top to bottom and from left to right, which is a nice thing. Below, you can also see a different statement. Take the data frame, then group it by character, then summarize it by counting how often each character occurs, and then count the unique characters. It really sort of feels more like I'm reading something from left to right, top to bottom, than, let's say, SQL, which you usually read inside from outside, especially if there's lots of joins. So this is the way that R sort of solved ETL, let's say. And it feels like a bit more of a grammar. Yes, it's kind of a library too, but it feels like I'm describing a language more than, let's say, a tool set. The whole point of this is that it feels like you're taking natural language, maybe structuring it a bit, and that you then have a nice user interface. The whole point is that this is a nice user interface. So let's just read this and figure out what this code does. Take the data frame, filter everything such that the race is an orc, then take every character, calculate the minimum timestamp and the maximum timestamp for each of these characters, take the mean of that, and then arrange that. I think this is descending. But I hope this sort of reads kind of well. This is definitely better than SQL, which is also supposed to be a domain-specific language, by the way. Just that this one seems obviously better. If you're not really used to R, though, there are these weird things in there, like this percentage sign greater than percentage sign. And one way to look at it is it's kind of like a pipe operator. The people in the R community like to call it a then operator. You do something beforehand, and then you do something with it, and you do that later. This is sort of R 101, but just to reiterate, suppose I have this function called money, an amount goes in, and I have a certain amount of interest, then I can calculate the amount of money I might have after a year. And what I can then do is I can either write down money, input is 103, or I can say, take the amount of 100, then pipe that into the money function, and automatically the first argument of the function is the thing that's going to get passed in. There's also some tricks where you can say, hey, don't place it as the first argument, place it as a second argument, use a point to basically denote that you want to place it somewhere else. But the nice thing about this is, you know, instead of writing the thing that's on top, that you really have to sort of decipher and read it from the inside back all the way to the outside, you can start writing things down in a logical sequential order. And we like that. At least in the Western world, we're taught to learn from to read from top to bottom, left to right. And if we're describing anything as something that's not that, then it might not have been written for humans. But R seems to be written for humans. And this is a great, great, cool trick. By the way, if you're using Keras or something like that, you're going to be using this trick to build neural networks. Keras works great in R. The whole point is, if you want to define a model, you just say, I'm going to define a model, and then I'm going to put an input layer on top of that, and then I'm going to put a dense layer on top of that with this activation and this many units, and then I'm going to make a dropout layer, etc., etc., etc. This, by the way, is a standard model for NNIST. This reads like a charm, and this is, like, what, 8 lines of code? Main reason you can read it from left to right. So R is a programming language that solved the problem that you want to read things from left to right. I know very little other programming languages that fully do this. So this is a nice and cool thing. The trick that R uses is R doesn't have a lot of objects. R has a lot of functions. So you can take an object, give it to a function, out comes probably the same object, and you give it to another function. R has that in mind, and that's how R is designed. That's all great. The main use case that you're going to see this pipe array operator for is for this package called dplyr. And dplyr is what has these functions like group by and summarize and arrange and all that kind of stuff. But I'm assuming that most of you aren't R programmers. So if you look at this code, just look at this. And we know that race and character class, they're column names of the data frame that we saw before. Can anyone explain to me what's super weird about this statement? And this is sort of a general programming question. Assuming no knowledge of R whatsoever, there is something super weird about this statement. Or there should be. even if you understand the pipe. There's something in here that should immediately make you go, what?
Was it minus 10?
Minus the what?
Minus 10.
You're very, very warm. So if the minus n is weird, something else is even weirder.
You don't declare anything.
Yes, I think that you don't declare any n was the comment. And that's exactly correct. So character class, race, and I guess the n you see down there. If I were to go to the terminal, I would type in character class or race. It would say these are variables that are undefined. However, apparently R is able to infer that even though those variables aren't declared anywhere, that they're probably related to that data frame. In Python, you could kind of get away with this by maybe making a function that accepts strings, but here we're not doing any of that. And that's a little bit weird. That's very strange. I don't know of many other dynamic languages that do this. So the character level variables are not declared anywhere. So what is happening here? How the hell is R able to sort of deal with this? Well, the internal trick that is being used is that such a code block is actually not evaluated the moment you write the function down. It's evaluated much later. What R can do is it can take all the inputs that you give it and just not execute it at all. It can just keep that code and wait. It can wait until no other function's there, and then it can sort of internally check, oh, what is this variable supposed to do? How should I interpret this? And this should get your mind boggling a bit. Apparently it's possible in R to write your own language of sorts, because no matter what you put in there, you can always interpret it the way you want. And to sort of exemplify this, here's a couple of examples. And I'm going over this very fast. You're not going to sort of go home and be able to do any of this. But here's a simple function. I have a function that takes in a data frame, and then there's a couple of expressions that I can put in. And I can enclose those expressions. And I'm saving them in some sort of variable for now. But they're enclosed. I'm not doing anything with them. But I can say, let's exclose them later. So I can say, hey, take those expressions with 3 bangs, and then let's just push them in, and let's actually evaluate them. This way, I have made a function that can count how many things I have in each group, and I don't have to bother with strings or anything. This is one simple example. You can go even a step further by doing something like this. You can say, hey, here's a general expression, like x plus y. And this is sort of, computer science people, this is the AST, right? So you can sort of see the tree of operations that you have here. You've got a plus, and then you've got an x, you've got a y. And when you quote that into an expression, you can then later say, let's evaluate it. And the first time you would run this, R would say, meh, x does not exist, I cannot run this. In the global namespace, what you could do is you could say, hey, in this environment, let's declare x is equal to 1. And if I do the same thing again, suddenly y is not the thing that's found. And then later, if I declare y, then suddenly it's able to evaluate this. Some of you would rightly say, dude, I can do the same thing with a function. A function in most languages is also nothing more than exactly this, namely a bunch of code that will only get evaluated the moment the function is called. But note that I don't have to pass any input to this. I can rather freely, at least I hope it's intuitive that I can, interpret this in ways that I want. And this is a neat little trick if you want to make DSLs, if you want to make a very domain-specific language. And dplyr is one of those examples. For those of you that know Shiny, this is exactly how Shiny works. You basically say, hey, here's a little bit of a code block. You don't have to just put in a variable. You can even make a function that takes an entire code block, like multiple lines of code, and it will just delay the execution. Also, it gives you the opportunity to interpret the code as you see fit. Shiny uses this a lot, dplyr uses this a lot. It's a very, very cool trick, and it's a very powerful thing. Let's go back to dplyr. So we know that R has this freaky little trick that we can do things with ASTs, and we can sort of do domain-specific things with it. I'll now discuss how powerful that is for a language as R is. So let's go back to this code. I can read this code, and I don't really have to worry about the internals, because the externals really look good. I can sort of read, hey, take the data frame, group by character class, group by race, count the number of distinct characters, and calculate the mean level per character class and race, and then sort that descending. Yeah, that's what it's doing. And you kind of get a nice little data frame out. The fact that it's readable all comes from the AST. And I hope we sort of can appreciate this. But, OK, I'm now going to show you a bunch of examples of how R in general tries to produce grammars, and if you're actually going to use this, let's say on the World of Warcraft dataset, then we can get some fun stuff. The idea is that I just showed you something very technical, and we're all very tired of the technical thing, and now we're going to do something more light. So let's calculate some things with this cool data set. The first thing I was interested in is to figure out, hey, who's playing World of Warcraft? Are there more people playing in the weekend? Because if more people are playing during the week, then definitely World of Warcraft has some issues. Another thing I was wondering, in general, how long does it take you to get to level 60? I know, I work in IT, so I know a lot of people who got to level 60 twice. And I would really like to know how much time humanity has wasted on this video game, basically. Tons of people went to level 60. What could we have done better with that amount of time? And also, how much time was it? That would be nice to figure out. Another thing that's kind of cool to figure out is what could you have done to level up quicker, maybe? Would you level up quicker if you were a hunter, or a warrior, or an orc? Basic, business analytics stuff. So let's do some pattern stuff here. Okay, so let's first make a query per date. That's always good for plotting. So I take the data frame, I say, hey, take the timestamp, make it to a proper date. Sometimes when you read these things in, it's more like a string. I just want to have it as a date. And I want to calculate the number of distinct characters that are currently playing on that date. And then, by the way, we also have a nice little domain-specific language for plotting. You make a plot, and the first thing you're going to do is you're going to make a line chart with that data frame, and on the x-axis you have the date, on the y-axis you have the number of people. Let's have a look. So it's a shame that's kind of like 4 screens, but one thing that I do hope is clear, that's the beginning of 2008, that's the end of 2008, and we can see that in the beginning we seem to be going up a bit, people are sort of waking up after Christmas and New Year, and then there's a bit of a decline, a decline, a decline, and there's a kind of a spike, but in 2008 it seems that we might have had a decline. This was all visual bias. Let's now make a proper chart. And this is also to show how flexible the charting libraries in R are. Take ggplot, and let's also just make the same line we did before. And these are aesthetic. So the idea is that x and y are always sort of the base things in here, but we're going to declare other things that are aesthetic that have to do with the data frame. So let's also draw points, but the points that I just want to draw are the Saturdays. And make them steel blue, that's like a color, a very pretty color of blue. So take the Saturdays and draw them as points and add them to the same chart. Note, this is a layer of plotting, that's a layer of plotting. I'm using a different data frame for this layer than for that layer, and it still reads like a chart, I think. For you, and of course I'm a person who's actually practiced. What I do hope is at least intuitive. Have you ever seen matplotlib? Do this in matplotlib and then we'll talk. Probably after a year. Here I can say do the same thing but just for the Wednesdays and make those colors red. And here's one of the main features of the plotting library, and I cannot emphasize how great this is. I can add a title as well as a subtitle to my visualization. So the cool thing about that is I can say here's what you're looking at and here's what you should be looking at. And being able to do just that is a huge boon. Suddenly, I get less people from business analytics about the performance of World of Warcraft. It's not really happening that often. One thing we can see by just running this one visualization, I can confirm what I believed before. The blue dot, again, was a Saturday. This was the Wednesday. Definitely, people are playing more during the weekends than they are during the weekdays. There seems to be this weird outlier of sorts, and suddenly people felt like they had to play on a Wednesday. Probably want to look into that. But, okay, this is a nice little chart. And also, I hope it's slightly obvious. Again, here, date was not declared, so also all this AST kind of stuff is happening in here as well. And it's also a pretty plot. Mainly, I really like this. The subtitle is a very cool thing. Features. So just like dplyr, the plotting also occurs via a grammar. You can add layers with the plus operator. In this sense, the plus operator is kind of overwritten, such that we can say, basically, we're adding a layer, and we're adding a layer. And this also reads from left to right, from top to bottom, which is a good feature. And the aesthetics that we have depend on the data that's passed to the layer, and we've got some non-standard valuation happening there as well. The characteristics described in the aesthetics are common across layers. So if I wanted to add a color for the line or a color for the dot, that would be the exact same way. The only thing that's different is, am I using geom_point or geom_line? Grammars are nice. And there's also some R magic happening. But the main reason why people love using R is because of this grammar. There's a downside of this data set, though. So I have a pretty good laptop, but R, just like Python, is single-threaded. I can just only use one CPU on it. And this data set is about 600 megabytes, so I don't want to spend my entire weekend preparing this talk, and I kind of want things to go fast. So dplyr is kind of cool and all, but I don't want to be waiting 5 minutes for every query to run. It wasn't 5 minutes, maybe it's like a minute, but I want this to be very ad hoc. I want this to be very interactive. And currently with the dplyr set, that's not the case. So that means I have to probably rewrite this into something like Spark. Spark, of course, you can do it on big data sets, you can really do it in a cluster. I was using Spark just on my laptop. Why? Even though it's just one single laptop, suddenly I can use all 4 cores. Spark will just distribute that across the cores of my laptop. So that will already speed things up. But wait, I hear you say, that might mean that you have to rewrite all of your code. Because we've seen what happens to pandas code, and when you have to rewrite that into PySpark, that's extra time. We don't like that. The statement is true, but luckily in R, R really solves all that for you. You don't have to really do much. And we'll see that in the next example. So I'll implement everything you just saw in a library called SpaRkCRaft. This data set. The main task I have for now for this data set is I want to sessionize things. If I want to calculate how much time you're going to spend to get to level 60, there's a problem with this one data set. So let's say I am that character at this level, and I want to calculate how long this person was playing. I could take the minimum timestamp here and the maximum timestamp here. That would be fine. Then that's sort of an impression of how long the person was playing, maybe. And all of that's fine, except that this person took a break from 13:32 till about 4 o'clock. If I were to count all that time, I would be making a mistake. So I need to sessionize this data. I basically have to say, hey, a session started here and it ended there. So I take the minimum maximum of that session, and that's the total amount of time that was spent. And I have to do it again here. Otherwise, I'd be kind of cheating. The trick you have to do, and this is something you always do mentally first, just sort of in terms of data operations, what you can do is you can take the lag variable, and you can basically say, what was the time difference from this point in time to that one? And usually it's about 10 minutes. I round this to minutes. And then you get something that looks like this. So this is the first column that I add. And if you do that, then obviously there's going to be a bit of a spike there. There's going to be more time than just the 10 minutes you see there. So what you can then do is you can basically do sort of a true-false statement that says, hey, is this number larger than, let's say, 20? If that's the case, then obviously we will have started a new session. And then we get true, false, 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 and then true there. Booleans evaluates to integers, so if you take a sort of a streaming cumulative sum over this array, boom, you get your session ID. And you need to do this for every character, you need to do this for every level, but this is a nice way to get a session ID out. You just have to add 3 extra columns. Bit of advice, before you write any query like this, it's usually a pretty good idea to write out your battle plan on a sheet of paper before you actually start typing. Whenever I start at a company and I have these junior analysts that I'm helping out, they make the mistake that they first start typing SQL before they start thinking about what they're actually doing. Making a battle plan like this will save you hours and hours and hours of time, so please do that. Having said that, let's write this in dplyr. So let's first make sure everything's sorted in the right way. We arrange it by character and by timestamp. Then we're going to group by character. And then we're going to do the logic I basically just said. So I'm now going to take this query, I'm going to go through the immense effort of translating this into a Spark query. Whoa, that wasn't really much effort. The main thing that changed is the thing up front and the thing in the back. So let's look at that again. This was a normal data frame, and we wrote down WoDF, and here we wrote down WoDDF. The point here being, this is a different object. The idea is that's a data frame that lives in Spark. It's not a data frame that you usually have in R, it's a different type of data frame. But what R can do is it can take all of these operations, and you can save that into something called Q, and then you can ask R, could you explain it? And on your behalf, it will generate all this SQL code for you. What R can do, because of the AST, it can look at the entire dplyr query you've written and translate that into something SQL. In this case, this is what Spark code would look like when it's generated. Note, even the partition by stuff it's doing correctly. So if you're saying first group it and then apply a lag operator, instead of specifying your own window function like you would do in PySpark, it will just translate it into SQL like this. Oh, if you want to do BigQuery, that's the same thing. I mean, you just say it's a different backend. It's just BigQuery now. And this is super useful because there's so many different weird SQL dialects out there. And BigQuery definitely is one of them. And the fact that dplyr, because of all this AST magic, can say, I don't care about the backend, I'm just going to compile it towards it. You could do stuff like this without much effort. And that's kind of a really powerful thing. You really just have to learn this one DSL, and whatever backend you want to apply, well, we're just going to translate towards that. That's a very powerful thing. Python does a similar thing when it comes to numeric computation. When you write Python code, secretly it's running NumPy, which is secretly running C++, which is secretly running BLAS and Fortran and all that other stuff. The only thing that R is trying to do is to be a very expressive user interface language, something that Python does as well. Main difference being here, we're doing a little bit more meta-programming. We're doing more with ASTs and that sort of stuff. And to just brag a little bit about the backends that are supported, we've got normal R DataFrames, we've got more advanced R Tibbles. We can write this as SQLite, Postgres, Redshift, MySQL, MariaDB, MongoDB, Presto, Spark, Hive, Impala, Vertica, Teradata, and Google BigQuery. And this is a subset of things. There's also others being written. But the idea is if you write something in dplyr, you can very quickly translate that by just pointing it to a connection to a database instead, and it will work on all these backends. And that's a very, very powerful thing. It's very expressive. You can still read from top to bottom, left to right, and you don't have to look at this junk anymore. And Python people would say, that's not how a dog is supposed to work. Well, yeah, it's a cat.
With pandas, you have a backend to SQL Alchemy that does all of that stuff too.
Does it work on BigQuery?
I think there
So,
are.
so definitely there might be some implementations, and that's fair. But then you're writing SQL again, if I'm not mistaken.
BigQuery is another end. I mean, Java also has another end, so Hibernate is
Oh,
another
sorry.
concept.
True, but then, this is fine, but then you're not really writing pandas anymore. You're
You're
writing.
writing pandas, yes.
So pandas will translate to the ORM, which will translate to SQL? Okay,
That's the backend of pandas.
cool. So here's the thing. I also do Python, so I don't mind.
I know.
I'm just here to defend that this is kind of a cool trick. When you write it in pandas, can you read it from left to right, top to bottom? He's distracted. So, there's a few downsides that I do want to be honest about. I mean, I hope that I've convinced you that this is all quite elegant, it's quite nice, but obviously there's some downsides. And the main downsides have to do with the fact that there are these weird SQL dialects. MySQL does things differently and doesn't support everything that BigQuery does and vice versa. The main annoying thing that I came across, for example, is if you want to apply a window lag kind of thing, like the PySpark normal window that you would write in dplyr, Spark will gladly take any data type, while BigQuery will only be able to sort ints. It will not sort dates for you. That's something dplyr will never be able to fix. You do have these weird differences in the SQL that you're not going to be able to solve from R. Nevertheless, holy cow, a lot of backends. Sure, Python can do some of that as well. That's all super great. But this is a nice feature, and it's something we can sort of appreciate, and we're happy about that. Note that the functions that are passed aren't handled by R at all. So some of the functions that I'm using here, like the UNIX timestamp function, that's actually a function that doesn't exist in R, by the way. That's a function that only exists in Spark. Basically what R will do, let's consider this weird example. Here's something that you can write down. What you could do is this UNIX timestamp function doesn't exist in R. And what will basically happen, let's suppose I change the UNIX timestamp function into a function called megaton dinosaur head. The generated SQL that will be made will have this megaton dinosaur head in there. The idea here being, even if the function doesn't have an equivalent in R, just by applying a function that sort of has the same string, you can still have all the Hive functions that are documented. You can still have all the weird BigQuery things that are documented. You just pass it along as a function that doesn't exist in R. Sort of an extreme example of how the AST metaprogramming kind of works. You don't even have to have a function that exists to be able to apply it. So there's something very beautiful in there. All Hive functions should be available. If you just look at the Hive documentation, you can just copy and paste that function, drag it in, and it will still work. If you go down that route, you do have the small downside that not everything you write in R can automatically be translated into something in SQL. Does SQL Alchemy also do partitioning, by the way?
Yes.
Okay, that's kind of sweet. I should look at that. Another thing that R will do is if there's a couple of common verbs in R, like as character, if you have a column that you want to change into a character in R, R is clever enough to take, let's say, 80% of the things that you're commonly using, and then cast it into the SQL variant. So you can say as character, which is sort of how you maybe take a number in R and make that into a character, that will get translated into cast call name as string, implicitly. So some of that stuff is actually kind of nice. You cannot do everything, but a lot of this stuff is in there. So here's all the code that you need to sessionize everything. Here's the sessionizing stuff. Feel free to look at it later. Here's all the apply to statistics stuff. Feel free to look at it later. And we don't even have to look at the SQL code that's being generated, thank God. What we can look at is this result. So this is the time it takes. So this is the level that you have. And here's all the different characters. And here's sort of the time it took for that character to level up. And you can sort of do the math. On average, it seems to take about 132.6 hours, which is about 3 weeks of a full-time equivalent employee. 10 million people, you guys get the drill. All that wasted time on humanity, we could have also been learning R or something like that. So a couple of things. And again, I've been mentioning this for over 5 times now, but I don't want to stop mentioning it. The code we've seen in R thus far is readable from left to right, from top to bottom. It's very describable because you can use something like first this, then that. It's executable on many backends, and you can even optimize internally. Theoretically, what you could do, not every backend does this, but what you could do is you could look at the query you're trying to do, and you can do things like, hey, if you're going to filter at the end, if you do that earlier, then you're going to get a huge performance boost. You can compile things if you really want to. You can get that creative if you're designing this language. Spark already does this internally, so there's not really much need to do this from R, but you could go there for your own backend if you really wanted to. Also, if you're running it locally, from R, you have this, you first have to start up a Spark cluster locally, and then you can say, read the CSV. This is the Spark engine that you're going to have to be using. Here's the DataFrame, and here's the name of the CSV. Parquet also works, Avro also works. The common file types that you have in Hadoop are also supported. And you can do all of that from RStudio, so that's great. So this was all ETL and a little bit of visualization, which are definitely things we like doing. But what about machine learning? And this is sort of where it gets kind of awkward, because the backends are a little bit more splintered up. But as far as Spark is concerned, R still has your back. There are 2 options. One, you can run all this stuff from Spark. Spark also has machine learning libraries, and you can run that from R. There's these translation wrappers that you have. And another alternative, which is a little bit more my favorite, is you can also just run H2O on top of Spark. The idea is H2O lives in the JVM, and Spark lives in the JVM. So how about we just use this library on top of that execution engine and use all that compute power to use basically better machine learning libraries. Main features, if you're going to consider H2O, which are kind of neat. One, the grid search is much, much better. The grid search in Spark is rather limited. You only get the best model, but you don't get any of the explanation last time I checked. There's way more hyperparameters that you can tune per model in general. And when you've trained your model, you get this Java object, which you can give to engineers, and engineers like Java objects, because getting that to production is a lot easier than some random R function. That last one is actually the main reason why some of my clients have used it. Pojos are kind of nice. If you want to run that, this is kind of what the code would look like. So let's say ag.ddf is some aggregate data frame that's distributed in Spark. Let's throw away everyone that's level 60, because those people aren't interesting. And I'm going to be training a machine learning model now that will try to figure out, hey, are there any features that will decrease the amount of time that it takes for you to get to level 60? So a bunch of characteristics of characters, try to predict the amount of time it takes for you to get to level 60. And I'm using sort of a linear model with a little bit of, what's the name? Regularization. So the idea is I don't want these parameters from a linear regression to be very large, so I want them to be somewhat smaller. There's a hyperparameter for that. The idea is I have some sort of list, which is kind of like a dictionary, if you will, with everything that this algorithm should consider. I have a test frame, I have a train frame, and basically I can specify, hey, here's a giant grid search. Take this validation frame, take that test or train frame. Here's the X parameters, here's the Y parameter. Chuck all that in a grid search. You can also specify how the grid search works. You can enumerate everything. You can also do it randomly. But it's doing a lot of stuff in not a lot of lines of code, and that's actually kind of nice. A few observations, though. If we compare this to the grammars we discussed, the code we described really works, and it's rather clear. And the grid search feature is actually pretty sweet. It's much, much better than Spark. But it's a bit more of a library and a tool. It's not so much of a grammar. grammar is something you can read from left to right, from top to bottom, and you can keep talking about it. Whereas this, is more like a config file. Very, very useful, but it's not the same as a grammar. But let's maybe discuss that a bit later. But it's not a grammar. Super cool, super useful. We'll get back to that. Let's appreciate what we have when we run this, though. Because if you run this, while you're running this, it's also starting up a small little user interface for you. And what you can do is you're running a grid search. You can go to this one website, localhost 54321, and you can look at all the models the grid search has been looking at. You can click on the model, or you can sort of look inside the model. You can see all the model parameters. You can see the sorting history. And you can kind of see that the level is a very good way to predict how much time it's going to take you to get to the next level, which makes sense. If you're at a higher level, you're going to be taking more time. And then the next thing basically is if you're part of a guild or not. So yes, if you're part of a guild, you level up quicker. Spent an entire afternoon, that's what I learned. Also, it helps if you're a hunter. So just to recap everything we've done so far. We've seen that modern R packages prefer grammars, and we've also seen how this offers a lot of flexibility. It's expressive, we're humans, there's stuff to like here. And yes, simple alchemy also exists. I'm not saying Python is poor, I'm just saying R is kind of cool with this. It's very easy to learn as well, and it's very expressive. These are all great, great, great things. And I hope it's currently clear that R actually has a lot of nice features that are somewhat language specific, but also task specific that aren't language specific. Like even if you don't like using R, you can use R code to run non-R stuff. If you like Spark more than you like R, you can still run Spark from R. That's fine. But so far I've just been describing the language at this AI meetup, so you guys must be thinking, what gives? Surely I'm going to be presenting something more special than just R is a cool tool. And you'd be right. So to show why R still has features for the future, I'm going to have to discuss the model which I just made. And what I will argue is that the model that we've just made is horrible. It's the worst thing. And the problem with the model is that it's, instead of saying, here's the data and here's how I want to model it, what we're basically doing is we're saying, here's a type of machine learning model, and we're just going to put the data in there and hope that something useful comes out. Intuitively, some problems can be solved that way, and that's fine, because it's very reproducible and scalable and whatnot, but it's not expressive. So to explain what the problem is with that, let's consider a different data set. This is my favorite data set, the chick weight data set. The idea behind this data set is you have these chickens, and they're all given different diets. So chicken 1 had diet 1, chicken 50 had diet 4, and over time we can check how much they weigh. And just to show another awesome visualization, hint, hint, subtitle, you can see over time that the chickens are sort of having different diets. So some diets seem to be performing a little bit better, but this is sort of a plot we can make. We also see that as time moves on, there's more spread. So let's chunk this in a linear model, shall we? Let's just do the straight up thing. This is what you would do in scikit-learn and whatnot. It's also what you're taught if you're studying econometrics in the Netherlands. What you would do is you would say, hey, here's the variable that I want to explain, and that's dependent on the time and the diet. And typically if you do this, I think it's stats models as well, but scikit-learn, what typically happens is this diet gets translated into a dummy variable, because all the dummy variables intertwine with the intercept, and we'll throw one of them away, but this is what comes out. And I hope that I don't have to explain to you that this is all wrong. What we're doing now is we're saying, independent of what time it is, the effect of the diet is a constant that we're just going to be adding. I know about you, but when I look at this, definitely the effect of the diet is dependent on the time. It's not like if you're born but you're diet 1, that suddenly this is your weight. So modeling it like that feels at least somewhat preposterous. People do it all the time. And this is kind of a worrying thing. This is somewhat normal. An alternative that you could do that actually would be a whole lot better is you use this R trick. In R, data frames can have data frames. So what we could do instead is we could do something like, hey, take this chick weight, group it by diet, and then nest it such that this is the data frame that belongs to that diet. And then we can train a linear model on every set there. And this would already feel a little bit better, because it does mean that the slope, at least per diet, is specified. But this would still be wrong, because the intercept for every single one of these models will be different. And if there's anything I know about chickens that are born that didn't get a different diet, is that they should be modeled as having the same weight. We shouldn't have a different intercept here for different diets. Beforehand, we can use our domain knowledge to know that they should all have the same intercept. So even though I think this will be relatively okay, it's still not the model that I know should be applied. And there's something wrong here. In essence, in machine learning, it feels like we can pour data into a predefined model, but it doesn't feel like I can really define the model much. You can get away with a lot, though, because let's be honest, you can sort of mimic the features I want in this model by doing feature engineering in a very, very proper way. I guess what I could also do with this data set, I can also maybe add some features here that mimic the slope for every single chicken that's a little bit different. I can also put that into the model.
Just add an interaction term?
Well, sure, but here's the thing. It feels like, but I do believe in separation of concerns. If I want to be playing around with the model, I should be playing around with the model. I shouldn't be fiddling with features. Just like if I'm making a plot, I shouldn't be doing features generation for the plot while I'm making the plot. That should be done beforehand. And currently, it feels like when I want to make a very special type of model with my domain knowledge, there is no separation of concerns. And that concerns me. Because really what I want to do is I want to have some sort of DSL, because I can write down on a piece of paper what I want. Because I just want to have a linear model where I say the weight of the chicken, it has a beta 0 and a beta 1, and this guy is dependent on, it's the same for all the chickens, and this one's dependent on the diet. And what I would really like to do is just make a picture of this, so that the computer understands it, and then we can then say, oh, right, this is what you mean. I'll generate the model for you, because I can do that. And this is why, if you're sort of an ML purist, you would look at Python stuff, you would kind of say, your cat's broken. Because in R, people have thought of this. The idea is there's this lovely little library called map-to-stan. The library is called rethinking. And has a very cool function called map-to-stan. And the idea is it's kind of like a very simple DSL for models. It's a bit limited, and everything's defined probabilistically. But the idea is you can say, hey, the weight is sort of distributed normally with some mu and some sigma. And the mu is defined by some intercept and a slope that's dependent per diet. Oh, and this will be multiplied by the time, by the way. And then the slope of the diet, well, let's give it a prior, let's be a Bayesian about it. And the intercept, oh, that's the same for everything, by the way, and let's do the same thing for the sigma. And in this case, I would say take that data frame, and because we're doing stan, let's have a warm-up of about 500 iterations. And this is what the model will sort of provide you. Not only will it sort of run this and sort of do the optimization for you, but the variables that come out are distributions as well. What you're seeing here is a mere visualization. What comes out is actually just a nice little distribution. So we even have cool Bayesian tricks that we can do, because these are distributions, which is awesome. But thinking back, even this model is kind of poor. And this you can also do with feature engineering. But the thing I really want, I hope you remember, the chicken weight data set was sort of spreading over time as well. And currently this model has a constant sigma. All right, maybe I want to change it a bit more. Maybe I just want to make a picture of this and give it to the computer and have it do things, where I say, hey, the error term that's being generated, the noise thing that I have over here, let's say there's something constant, but also something that depends on the time, and maybe even on the diet of the chicken. Okay, type, DSL, DSL, AST, AST, translate to some backend. And done. And we can make training test sets with this. We could go there. What we can even do is we can do very cool Bayesian tricks, like do entropy, kind of like a FoR or what have you. But just this is very useful for me, at least, because many of my clients, they have a lot of domain knowledge. The only thing they need is some person to just tell the computer how the world works. And let's be honest, a random forest does not do this for you. A neural network does not do this for you. A linear model might, at best. But usually even there, you cannot really do things with hierarchy. And this is a bank, right? So if I were to model house prices, not only would I sort of maybe want to make this probabilistic, but I would even make it hierarchical. I can really think that the house price, if I think about it, if I think I know how the world works, I can say, well, the house price is probably dependent on the square meters of the house times the price per square meter. And the model for this might have some overlap, but you can sort of make a giant tree of things. Here comes the Bayesian argument. If you do this in a fully Bayesian way, you can define a system like this. It would be nice if we have a DSL for it. But you can make a system like this. And then we can be even flexible by saying, if I have these three things, I might have some noise here, but I can still predict the house price. But let's now say that I know the house price and the number of square meters that I need. Maybe I can then also infer what type of house I'll be living in. Or maybe where I'll be living. So such a model would also be much more flexible in terms of what you can ask it, because you can actually actively deal with missing variables at the same time. All the features I just mentioned at the moment aren't available in sort of the more common machine learning libraries, like scikit-learn. But you could model things this way. It's just we're missing a very nice language. Hint, 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 hint. So most of the cool things we just saw, like the things we could be doing, is all a result of this non-standard evaluation that occurs in R. I certainly think it will be possible that you can do it in Python. That's fair. The thing I would like it to be, I would like it to be very expressive. I would like it to be very readable. I would like it to be very teachable. I want to see a little bit of code and kind of go, ah, right, I understand the configuration file immediately. A logical next step for the ecosystem, because we have to remember where we came from, this whole really applying the AST, the whole tidyverse thing, that's all fairly recent. But a logical next step for the R ecosystem might be a convenient language for models. We have a grammar for visualization, we have a grammar for data manipulation, but one for models is, people are working on it, but we haven't really gotten one yet. But as far as I'm thinking, R has a good shot of surviving this whole data science winter, what you will call it, because we can do stuff like this. We can design something to be independent of a backend, because we are now standardizing what a data frame might look like. And let's be honest, to do the things we need that I just described, I need probability distributions, matrices, and a bit of calculus. Tensors are also going to be independent. You can already use Keras, you can already use TensorFlow in R. We're independent of the backend at this stage. And this combination will probably make the next 5 years very interesting, because I think this is probably going to be happening. Maybe something like this, something where you can say, here's a hidden Markov. The probability of y given the previous value of s, that's distributed normally with some mu. You can basically write down the math that you're used to from LaTeX and maybe generate a full model from it. And that would be a cool thing. What you could probably do then is define a model like that, and then say, okay, here's the model, make it. The backend has to be TensorFlow, and let's use MCMC as the optimizer. Or PyTorch and use the method atom. You're not going to be as Bayesian, but sure, it's going to be quicker. Or some of these models you can actually kind of translate, if you do the feature engineering, into something like H2O. Then you still get the POJO out. But then this will automatically handle all the kerfuffle with feature engineering for you. All of this still has to be written, but it's kind of nice to be able to write your own DSLs. Because designing a DSL will be very, very hard, but just to sort of get you guys excited, you should be able to come up with verbs, hopefully, such that you can declare the following models fairly easily. A latent Dirichlet allocation, LDA, the topic modeling thing. That's a probabilistic model. You should be able to define that. TrueScale, hidden Markov models, domain recommenders, they can all be described with just a couple of probability distributions. So it shouldn't be that much harder to just have that be the user interface. And once we have that, then you're only going to be limited by your own creativity. So the UI, is still going to be hard. But once it's dreamt up, I think things are going to get very, very exciting. We're getting near a standard format for exchanging data frames. We've got Avro. We've got Apache Arrow as well. We're getting near a standard for numeric things too. Tensors are becoming quite a standard. Even if you don't like TensorFlow, you can use PyTorch. You can interface with it. And this grammar for models might actually become a thing. I wouldn't be too surprised if the first version of something like this working will be happening in R. That's simply because of the expressiveness. And because that's so powerful, I am very, very happy that I learned R. I should also mention there's plenty of bad things about R too that annoy the heck out of me. Right now, I'm at a client and I have to build my own logger for Docker because the R library doesn't have a proper logger yet. That's super annoying. And if you have arrays defined like this, the one thing that's annoying is all of them will give output, but you can't always predict what the output will be. Try this out. It will all produce an output, and the surprises will frighten you. It will not even give an error. So, I'm a fan of R. It definitely made me a better professional and a happier human. And I hope that sort of this vision I gave you, I'm hacking on it independently. I know a couple of people are also sort of thinking about this sort of stuff. I think it will happen. I don't exactly know how, but it does feel rather apparent that you're going to want something like this, and R might be the tool rather than. Having said this, there's parts that I don't like, and obviously I love Python too. I wouldn't be organizing all these conferences about Python if I weren't. I even like Golang. I don't know if you've tried Go. There's some very cool things in that language. If you want to make very small binaries and just do one thing and one thing well, Go is super lightweight, and I love it. But one thing I do hope that we can kind of maybe get started with it does feel a little bit strange for me to have to defend R to the Python crowd. Because it really feels like I'm talking about dogs to cat people. And if you wonder what it's like to organize a PyData conference if you love R, it looks something like this. So, having said that, there's a couple of announcements I would like to make tonight. I'm still involved with the PyData, and PyData Amsterdam is looking like it's going to happen. We still need to have a couple of things signed off, but PyData Amsterdam will happen probably end of May, beginning of June. Please talk to your employers for sponsorships. But also consider sending us a call for proposal, if at all possible. Another small announcement, we're also going to be organizing Saturdays, which is kind of the R variant of PyData. This is a somewhat bigger event. This will be a somewhat smaller event. It will be single track. It will happen around September. The idea is to have like a one-day, maybe a workshop day, where people can talk about R and hack with R a little bit. This will be the big event. This will be a smaller event that will also be happening. The R meetup will also be getting a boost, because we're getting some funding for this. So let's get people working together to make the future a little bit better. If you set your mind to it, good stuff can happen. My name is Vincent. Are there any questions? Yeah.
You have quite a complex mind.
You and my girlfriend could have talks all night. Yeah.
Yes, the meta programming. So I would like to ask you a meta question.
Sure.
When you spoke about sessionizing the data set, right? We had this difference of minutes, and then you applied an if to have a boolean.
So this one, right?
Yeah.
Yep.
And then you synchronize with one issue. And you mentioned that when you run your company, your juniorish friends, they were kind of typing before.
My clients.
Ooh.
Small difference.
So I would like to know, which kind of strategy do you use when you have to put a piece of paper and try to figure out what could be the outcome? Because personally, I prefer coding instead to do the paperwork. Do you use some mind mapping things? You just sketch and you fill? Do you use some strange strategies?
Pen, paper, and common sense. I'm sorry. So the thing is, the main thing I would argue, and of course, I know plenty of people who can code things up and it will work, and that's fine. Not everyone's there yet, though. Especially, I think, if you're a little bit junior, a lot of this stuff is complex, so you might get lost in the syntax. For those people, I would definitely give the advice.
Especially without log.
Well, the main advice will be, solving this, for me at least, was much clearer when I figured out, hey, what columns do I need to be making in what order? Oh, right, and then I could write it up quite quickly. That's sort of the way I like to work on things if I know what I'm going to be doing. Like, if you really want to do it properly, you're also going to be writing some unit tests, right? Just to be sure that all this works. But in general, it's, I don't use mind mapping software. I don't practice Buddhist Zen or anything. I just, I talk to a colleague, have a coffee, and I draw things on a whiteboard. Yes?
A question. You mentioned several times, you mentioned the ASTs, and so basically during the compilation phase of the code, or actually the...
Oh, okay, so it's not like C++ compilation. It's more that you can take the expression, do things with it, and later run it. And that doing things with it, that's what I refer to when I say compiling.
Yeah, so basically, you're talking about AST transformation, so macro programming. Macro programming you also mentioned, which basically makes me think of augmenting with some macros.
Yeah, so
the library of macros,
I'm going to say
of R.
I'm going to say yes to a lot of the stuff you just said, but the main downside of this is in the industry there's a lot of words that mean so there's a word that could mean different things but still be the same word, and there's words that are different but mean the same thing. So yes, all the stuff that you say about macros, sure, that sounds very familiar. I don't know if it means other things as well, though. I'm not very formal when it comes to programming. That's the one sort of thing I would like to add.
AST transformations.
Yes.
Not just
yes.
patching stuff in C, like C++, but
no, then we're on the same page. Yes.
And have you considered, like, there's this whole thing of the functional programming, the type system kind of crowd, talk about sort of algebraic types?
So I do know people in Scala that are sort of doing things here.
Uh-huh.
Those people do exist, and I do think that whole type system, if you have a very proper data structure and type for a probability distribution, boy, that would speed things up.
I'm talking about the DSL, where you can basically represent the DSL as a set of objects, of
Yep,
base
no,
values,
so-
and then create your program as a data structure, basically as a list of statements, and then pass it to an interpreter, which can do the kind of thing
Yeah,
that
so-
you
so
mentioned.
I know that
there's a SQL library for Scala that is written like that.
Yeah, so I know that Scala people are working on this, and to be honest, I think there's properties of Scala, not being a Scala programmer, that seem like beneficial to what we're trying to do here. I do like plotting though. Like, I really like plotting. And Scala, I think, will never be able to supply me good plotting.
I'm not trying to say move to Scala. I'm just saying, is there any support for this kind of approach in R, or do you actually need to become a
No, so it's
compiler hacker?
so if
That's
you
kinda
really
like a
if you really want to do proper type stuff, R is a dynamic language. So there are some limitations there.
You could make the types not actually the types you're working on. The types would be the statements.
Yeah, so definitely you can go all freaky the way you want, I'm sure. But in general, what R does is it's not a very strict type language. So there are some trade-offs there. Definitely, I know some Scala people who are doing interesting stuff. I think R is a little bit more accessible to humans, though. I don't know about cats and dogs, but humans. But definitely people are working on it. And if someone has a very nice DSL that makes it very obvious what you're doing and at the same time very expressive, I'll change the Scala instantly. We're not there yet. And again, I'm not suggesting this is in any way a solved problem. It's just R is a cool tool, and I wouldn't be surprised if these sort of features are going to be coming to R. The rethinking library, by the way, already exists.
Okay, one more questions? No more questions? Anyone? Okay, so please thank our speaker today again.